theorem. The statement of this particular theorem is that the tangent at a point of a circle is perpendicular to the radius through the point of contact. I'll just explain what they're exactly talking about. So we have a tangent over here. Okay, right? That is a line. It's a secant which touches the circle at a single point. So this is touching the circle at this point. Okay, we'll call this as point P. This is the center. So from the center, if I draw a line, that's the radius, right? OP is the radius. What they're telling is, if I call this XY, the angle between OP and XY, there exists an angle, and that angle has to be 90 degree and nothing else. Okay, this is the whole theorem. So before I begin the theorem, we need to know few facts. Any point that is within the circumference is known as inside the circle. Anything that is on the circumference is on the circle. Anything that is outside the circle is known as out of the circle, right? It's very simple. So inside, on, and outside. So when we're talking about something that is inside the circle, that will have a length which is less than the radius. It makes sense, right? Anything on the circle will be equal to radius. That is the length from the center to that point. And the length from the center to anything outside will be greater than the radius. Make sense? This length is less than the radius. Obviously, this length is equal to radius. Again, obviously, this is more than the radius. This is more than the radius. Right? This you need to know. Okay. So let me erase the. Yeah. So basically, this is your diagram. Now we'll start with the proof. So first we'll describe the diagram. Okay. They'll just give you this statement and they'll ask you to prove. This won't be more than 2 marker. So we'll begin with, let's consider a circle with center O and a tangent XY drawn to the circle at what point? At a point P. Okay. Now, next thing is to prove. What is that we need to prove? OP is perpendicular to XY. Next is your construction. So what is that we need to construct? We need to join. So thing is, we need to prove that this is the shortest length, right? The way to do that is consider a point Q. Okay, that's not visible. Point Q that is on the tangent, but not, it's not P, anything else. So join OQ, where Q is a random point on the tangent. Next is proof. As point Q is outside the circle, right? OQ has to be greater than OP. Reason being, OP is radius. So with this in mind, we'll just write, since it happens for every point, because every point on the line other than point P is outside the circle. This happens with every point. Since every point on the line XY except P, point P, this implies OP is the shortest distance. Shortest distance from the center to the tangent. So if this is the shortest distance, what can we tell? So this is a kind of axiom, right? One which is true without proof kind of thing. So OP has to be perpendicular to XY. The shortest length from a point to any line is perpendicular. Okay, this is something that we need to know. So this is the proof, hence proved. So now you can pause and have a look.